and we will do a DRO departure maneuver. This
break the
again
hubble,
firing
man.
up that orbital maneuvering system engine and others on the
broke the
service
hubble.
module.
Hello everyone, welcome back to ZomBo Land Gaming. I'm so excited. I've been waiting for like months and months and months for this now, and years really for the whole project, but
Artemis is different than
look at
Apollo
that, we got
because
Jack
we're
Black
returning
on.
to the moon,
I had
but
to
this
skip
time
the
we're going
yo-yo
to
mod that
stay.
just
So
played
rather
because
than a
probably
short
copyright,
visit
even
where
though
we
it's the
can
Star
do
Spangled
some
Banner,
amazing
probably
science, but it was
copyright.
pretty
But
limited by
anyway,
these short visits, kind of a small area of the moon. We're
12
going to the
minutes to
South
the
Pole, and we're
2-hour
gonna learn how to
window
live there
for the
long
Artemis
term.
launch.
So we're going to be building
We've
habitats,
got
we're gonna
perfect
have
weather.
rovers, we're gonna
It
have
seems
all
like
of
the
this
hydrogen leak is under
infrastructure on the
control.
moon
I
supporting
think we are ready to
scientific
go, so
discovery, but
I'm going to
also that
shut
next
up,
big step
and we're
to
going
I
to
love seeing
let the
celebrities
astronauts
also take
talk
part
and
in
the
that
other
question
media
because it really
consultants
shows
talk
that
and
this
the
is
launch
something
control.
that's captivating
And
a lot of people.
woo,
So that was
I'm
really
so
fun to see
excited
Jack
for
Black.
this. I mean,
Also,
if you
clearly
saw my
looks
James
for
Webb
a
Space
seven.
Telescope, I'm
Funny.
even more excited for
All
this
right, let's
because
go
this
to
is
the
getting us
second
back to the
question.
moon.
How does it feel in space?
Being in space is amazing. I mean, for us,
It's a
launching
vacuum.
to orbit around
You'll
the
live
Earth
for
and then go
a
to the
couple
space
minutes
station, where
and
I
die.
just was for 6 months. We're in an apparent microgravity environment, so
Blech.
for us, it feels
NASA,
like we're weightless, like we're
NASA,
floating. So you have
representing.
to relearn how to live and work in that space. But once you get used to it, it's a lot of fun.
Yeah, we were just talking. Jessica Watkins, another NASA astronaut, was just
I
here.
can't remember
and she
her
was saying
name,
that actually when you
but
came
she
back on Earth,
was
that
one of the
was an
first
adjustment as well
females
because you got
on
so
board
used
submarines.
used to living on the space station.
Yeah,
Hopefully they'll say
the
her name again.
transition
I
home was
completely
actually
forgot.
a lot
I'm
harder
terrible
for me
with
than
names.
The transition up there because
Half the time
our
I don't remember
vestibular
people's names at
systems
work.
kind of remap. We start ignoring all the sensors in our inner ear.
Look at
that
that
tell us
big
how our
old
bodies
beauty
are moving,
sitting there on the
because
launch
the space
platform. I
environment
think
is so
the
strange,
rocket
but
core
we really need that on Earth to balance and
is
control our bodies.
212 feet
so when
tall.
we get back, it takes a couple
I think the
of
whole
days
thing is
before we
like
feel comfortable
just
again.
slightly
Really
taller than the
interesting.
Statue
Thanks so
of
much
Liberty.
for those. Okay, so we are 10 minutes until the opening of our 2-hour launch window today. So why don't we head back over to Daryl. Daryl, tell us what's happening.
Hello, Daryl.
Yeah, Megan, we actually have about 10 minutes before we go into a half-hour
They had an Ethernet
hold.
switch problem with
That
the
half-hour
radar
hold
stuff.
is
I think
part
they
of
got
the
that fixed,
L
hopefully.
clock, and what you see
And then the
on
hydrogen leak, like I
launch
said, is
right
taken
now,
care
I
of.
believe is the T clock. So in about 10
God,
minutes,
I
we'll hold
wish I
for a
was there.
half-hour,
I was going to
and
take a trip
currently
down
the
there
launch team
before
is
the
trying to
hurricane hit.
evaluate how much of a delay may
And then the
result
Queen died,
from
so
some
her
issues
funeral
that
also
we've been
took
facing,
one of the launches.
over the past hour. Just to recap those, we had a leak in a replenish valve
There he goes.
on the mobile launcher.
Where is my
that
mouse?
feeds,
My mouse
into
is
liquid
behind all the
hydrogen
Legos.
core stage tank.
Let's see if we
That's
can't.
been resolved. The leak has been fixed, and we're moving forward. Currently,
There we go.
the upper stage of the rocket for liquid hydrogen is roughly 78%
What do
at
they
the
say the
moment.
conditions are right
So
now?
that is tracking. Progress continues there. The core stage has been topped off, and now both liquid oxygen and liquid hydrogen
not
are
scheduled.
100%, along with the upper
Oh, that
stage
didn't really say much on there.
of the liquid hydrogen side.
Look how freaking
of the
cool that
equation.
thing is.
So
I would
we're just
love to be
waiting
able to work for
on
NASA.
the complete tanking
Or
of
SpaceX,
the upper
really,
stage
at this
of liquid
point.
hydrogen. Now,
Blue
with
Horizon.
regards to the range issue that we had, we just got an update from the range, the 45th Space Wing
Oh, yeah, here we go.
officer reporting in to the NASA test director that the Ethernet switch has been replaced. This problematic switch took down
Yeah, it was basically
their
not
ability
allowing
to
data
see,
to come in at a proper
radar
rate.
from one of their assets, which is key in getting acquisition and signal
You
for the
kinda
flight
need to make
termination
sure the data you're
system
getting coming
if it
in
were to be needed.
is sending back
of
to
course,
the
this
rocket.
is a critical system.
So this is an
has
unmanned
to
launch.
be
For those of you who don't know
tested
much about what the Artemis
before
1 is,
we can
we are
launch.
basically sending it
So at
to
the
orbit
moment,
around
we're
the moon
looking
and come back,
still
proving
at a
that we can get there
1:04
before sending an
a.m.
actual
Eastern
manned
time
mission. Because this is the first time
launch.
this rocket
But it is pretty
launching.
clear from the work
Whoa,
that is
simmer
ahead
down
that
there, Discovery.
it looks like we're going to slip into that window. How much
So this
exactly?
is from Block Zone.
We
and then
don't have
the
an
Hubble
accurate
Space
calculation
Telescope
from
actually
the
goes
launch
inside
team
the Discovery
as of
Space
right now.
Telescope.
But of
I
course,
think you guys
we're
have seen my
anticipating
Lego crafting video
so for the
of
moment,
this.
you
I don't
see
know
on
if I
your
did
clock
one for
now
this
we
guy.
are in the T-minus 10-minute hold. We just entered that, and now
I
roughly
really
we're
hope
looking
it
at
goes
28
off
minutes
sooner than the 2 hours, because
to,
I've been up since 5:30 this morning, and
resume
it is
terminal
now
count. The launch
9
team
minutes
will
till
assess
midnight,
what
Tennessee
work
time.
needs to be done, how that syncs up with the range getting
I really
back
should have gotten my
online
car yesterday
with
and drove
their,
down there.
with their equipment, and then we should have a new T0 for you soon.
I think it's about
That's the latest from
13
Firing Room 1
hours
here at the
for me to
Kennedy
drive
Space Center.
down there. Maybe,
Megan,
maybe
back to
it's Orlando.
So things are obviously still very dynamic. We're going to come
10
back
hours.
to Daryl as much as possible. Now, to understand where we are going, we have to know where we have been. To do that, we spoke to some of the special few who walked on the moon and those who sent them.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
It's been 50 years since we've
Can
been
you
to the
imagine
moon.
it being
We've got
alive
a great program
to
called
watch
Artemis.
that
We're
live, the
going
very
back.
first space
The
launch to
Apollo
the moon?
program was a test for the American people that you can do
Not just to
what
the moon,
you set out
just
to
to
do.
orbit.
All it took was turning to it and making it happen.
We are go for a mission to the moon at this time. Engines on 5, 4.
We could make a better SLS than what we've made here, and that's to come. You know, the way this typically works is government tries it, and then it goes out to private firms like SpaceX and all that sort of stuff. And I think this is going to prove that we can do it, and then private companies will make this a whole lot more efficient and better. That's part of the thing that we're going to the moon for, is that way we can then launch from the moon instead of launching from Earth. That'll save fuel, that'll save time, that'll save energy, be much more efficient, and we can get our resources for the launch.
The nation was almost euphoric.
That's one small step for man, one giant leap for mankind.
There are so many things that we could eventually learn about our universe and the spacecraft that we use exploring.
I've got my camera now, by the way, from my telescope, so come when it's not
We
so
are a
dewy
nation
and
of
moistury
explorers.
outside. Those
During
are words, those are
Apollo,
scientific
we were
technical
on
words.
national TV
We're going to be taking some
literally
pictures. I'll
every
probably do
day
some live
because we
streams
were
with
doing
the
something
camera
visible
and the telescope.
that Americans could see and they could feel and say, look what we are doing. And I believe Artemis is going to come up and say, look what we are capable of and what we are doing now.
We also need to look into the Chinese space station. I wanna see if we're able to see that up in the sky, and just to kind of see what missions and
Artemis
stuff they're
will
doing.
stand on the
Really
shoulders
interested. It looks pretty
of
cool.
Apollo. They're going to have the eyes
It's
of the
obviously
world on
newer
them
than the
when they start down
ISS,
this
you know,
trail.
both in technology and just what it looks
The
like.
science of space flight is one that will continue to inspire. Going to the moon generates technology, more communications.
One of my goals is to get a picture of the ISS going across the sun.
Manufacturing that
be a
help
cool
us
picture.
in everyday life.
We have a generation that is ready, a generation with that technology, a generation with the education. Artemis represents the future in space. It is our next big step, and it is time to take it.
If you're just joining us, welcome to NASA's Kennedy Space Center, where we are showing you a
Hello,
live
people
look
at
of
the
another
Space Center.
visitor center. This
wish
is
I
the
was
US
there.
Space and Rocket Center. Wow, take a look at all of those people who are there, hoping to watch the launch today. You know, this is the visitor center for the Marshall Space Flight Center in Huntsville, Alabama. That center played a crucial
I
role.
could've- that's only a couple hours away.
Contributing to the Artemis program. So I'm not surprised that there are a bunch of people there watching. All right, so now we're going to take
been a few years since I've
go
been down
back
there.
to Leah Martin over at Banana Creek. Again, that's right outside of our visitor center, and she's with some other folks who came out to watch today's launch.
Yeah, you know, Megan, we talked about this being America's rocket, right? Every state in the United States has contributed to this rocket, so it should be no surprise that we have people from all over the country joining us here tonight. I'm actually joined by some friends of ours who are joining us from Georgia and Utah. What does it mean to be here tonight to see tonight's launch?
I think it's amazing. I know that tons of people from all over the United States have helped build the rockets and are here tonight, so it's awesome to know that we all have a little bit of personal ties to the rocket.
And go ahead.
No, I'm just excited to be here because I've been a fan of space travel and going to the moon and back, and I'm glad to see it's happening again later in life.
And you were actually telling me a little bit earlier that you grew up in the Apollo era in those years following those first launches, and now here, how does it feel to be watching the sister program launch and seeing at the beginning?
Look at the goosebumps. That tells it all right here. I'm totally thrilled to be here.
Fellow space
Yeah, and
nerds!
you were actually telling me that you have a personal connection to this rocket as well. You know some people who have worked on it. What do you think it feels like being here? How does it feel for you to see something that's the culmination of so many years of hard work?
Yeah, I think it's crazy when you think about how long it takes to build it and stuff. Like, I wasn't even born last time people tried to get to the moon. So it's awesome. I think it's so exciting, and I cannot wait.
Neither was I, lady.
And we have a ton of people who are working tonight still on call, so we just want to tell them words of encouragement. What more do you have to say?
Oh, I hope it goes tonight.
Megan, back to you.
Me too, brother. Me too.
Go Artemis. Yes, I love that.
It's
And
only
again, I
had,
just
what,
love these
8
drone shots that
delays?
we're showing of all the people who are here, ready, hoping.
I mean, legitimate good delays. I mean, we don't want a
anticipating,
hide link to
today.
go
So
kaboom,
now let's head
right?
back
We
over
want to prove
Dan.
that this
So
is going
Dan
to
is
work,
in
and we have to have the
Apollo
right
Saturn
conditions.
V Center, which is right next to this crowd that you're seeing here.
Wow,
He's
look at that.
inside there, and he's going to tell us more about SLS using an interactive, state-of-the-art tool we're calling the
Ooh,
Moon
state-of-the-art interactive.
That's right, Megan and everybody. Welcome back to the moon board. So just to recap, SLS out on the pad, on the mobile launcher. Daryl's been walking you through all of the tanking, all of the preparation. We had that hydrogen leak that was in the base of the mobile service structure here. That's been remedied.
Guys,
We
I'm
haven't
so
had any
sleepy.
issue with those tail umbilicals that we were tracking so closely back in August
Excited, but
and
sleepy.
September. So everything looking really good with SLS. Just to recap, most powerful rocket we have ever built. It's propelled by 2 solid rocket boosters and 4 engines on this core stage. Now these solid rocket boosters are going to be firing for the first roughly 2 minutes of the flight, a little more than 2 minutes. And we call them solids because of the type of propellant in there. If you forgot it already, it's aluminum powder, ammonium perchlorate, and polybutadiene acrylonitrile. It's a binding agent that's inside. Solid propellants are extremely stable.
Acrylonitrile.
They're very reliable.
That's what a
but
word.
once you ignite them, they're going to keep burning. You can't really throttle them up and down like you can with liquid-fueled engines. You can throttle just based off of the distribution. So you basically put more propellant in some areas and less in others as you're trying to really throttle the rocket
My
down,
yawning
which we
shows
do
me not
as
being
we go
excited,
through
but
things like maximum
I'm still
dynamic
awake
pressure.
because I'm
And
so
just a
excited
reminder,
for this.
These things are firing. They can steer, they can gimbal. The bottom part here, gimbal just means you can really direct, and they're providing 90% of the steering as SLS is making the flight uphill, and more than 75% of the thrust.
I can't keep a
with those
damn
two firing
labeling
at the
machine
same
working
time.
at home.
And again, they're attached to this. This is the core stage, 212 feet tall.
gimbal
the
that
largest
much
single
thrust.
stage we've ever constructed. It's been
200. Yeah, I was right. 212
tests,
feet tall.
A lot of preparation for this flight today, and it is propelled by these 4 RS-25 engines. Now, these are liquid-fueled rocket engines, so you have a fuel and an oxidizer. And one of the great things about liquid fuel is you can throttle them in real time. You could kind of like the gas in your car. You can go faster or a little bit slower. So these throttle up to 104% of their rated thrust at the time of liftoff. We throttle them down as we go through max Qs, the maximum amount of pressure on SLS on the way uphill, and then throttle them back up until they've consumed all of their propellants. And they're consuming that propellant at more than 1,500 gallons a second. That is just an astronomical amount of fuel that's running through these engines to produce
don't
that
complain
thrust.
about
Each of
your
these
20
up
miles
to
per
500,000
gallon.
pounds each during their operation.
I don't even want to know how
of all
much
the different
money per
components,
gallon
we've
that
got this
stuff
engine
is.
block section down here. You have all of the associated plumbing, everything to feed those
Friends in
propellants
Washington
down
are
to
saying it's
these
like
engines. You also have
$5.50
these
a
two
gallon there. I'm
attachment
paying like
points here,
$3.30
and
a
that's
gallon
where
here in
we actually
Tennessee. I
tank
mean,
the
could you
SLS
bet
rocket.
that's
So a lot of
probably
focus on those in
hundreds,
previous
if not
attempts.
thousands of
They've
dollars a
cooperated
gallon.
spectacularly so far today, and we've been able to fully tank this core stage. And a reminder, you have a fuel, about 500,000 gallons right here of liquid hydrogen, and then an oxidizer. You need those two together, and then an ignition source. That's what gives you your reaction, your thrust, your
500,000
basically controlled
gallons.
explosion that then
Oh.
comes out of
Wonder
those
how much that
rocket
weighs.
engines. So fully tanked. These are cryogenic fuels, hundreds of degrees below zero. So we've got a spray-on insulation across the entire vehicle. As it's sitting out there in the Florida air, it's a little bit warm tonight, but we need to keep those hundreds of degrees below zero. It takes a lot of energy to do that, so the less you have to use to keep them cold, the better, which is why we have that insulation. So we're going to be seeing SLS take flight for the first time tonight as we clear all of those final issues. Again, this is going to be one heck of a
baby,
show
let's go.
when this thing launches into the night sky. So with that, send it back over to you, Megan.
If you're just joining us, welcome to NASA's Kennedy Space Center for live launch coverage of Artemis 1. I'm NASA's Megan Cruz, and this is NASA astronaut Kayla Barron. It's been great having you these past 2 hours.
It's been so awesome to be here for this historic launch tonight.
So right now we are awaiting
Kayla Barron. I'll have to remember that. I'll have to watch out for her because she's able to be on one of the next flights.
Those issues. So now we're just waiting
of
to
any
see
of the rockets.
a new T0, since we had been aiming for the top of the launch window, which opened does open at 1:04 a.m. Eastern Time. Now, today is a big deal.
Yeah, so
Apollo
that's 2 minutes
17
away.
in 1972 was the last time humans stepped foot on the moon. That the rocket you see right there behind us, illuminated in the darkness there, is the first step back towards getting us to the moon. Now, Artemis 1 is the first integrated flight test of NASA's deep space exploration systems. That's the ground systems here at Kennedy Space Center, the Space Launch System, or SLS rocket, and the Orion spacecraft. We will send an uncrewed Orion spacecraft farther beyond the moon than any of the Apollo missions
does that
before
thing
it.
look just
For Artemis
sitting there?
2, Orion
Ocean
will have
behind it.
astronauts on board
Oh,
as it
that
orbits
looks so
the moon.
freaking cool.
Then future Artemis missions will land the first woman and first person of color on the surface of the moon. So Kayla, why do we want to go back to the moon?
The moon's a super interesting place to study. It can tell us a lot about the Earth, its own formation, but also more about our solar system. And we also want to return this time in an international partnership for a permanent presence on the lunar surface that'll teach us everything we need to know to travel.
I'm talking about. That's why I love space so much. It's one of the few very international.
Have, the possibility of
everyone around the globe
selected for those
participates
future
kind of
missions
thing.
because they, the Artemis program, can choose from any of you guys, any of the NASA astronauts.
It's a crazy time to be a NASA astronaut, and even imagine that that could be real. I think we're all just honored to be a part of the team that's doing this. We're just a small representation of all the amazing human beings around the world.
And then, of course, the Artemis.
To do something as audacious as returning to the moon, learning what we need to go onto Mars. So we're just all excited to support the program in any way we can. But of course,
I don't know if
a ride
China
to the moon would be incredible.
has
So I think we're
just
all
Chinese
just
people
dreaming
on
about those
their
moonwalks.
space station,
now,
or
since
if
Artemis 1 is setting the
we're
stage
still
for
kind
those
of working
future
together.
crewed missions, is there anything in particular about this 26-day mission that you will be watching? Is it re-entry?
Yeah, you know, we've mentioned that a few times throughout the broadcast tonight. The re-entry is a really important part of the flight, of course, and the heat shield, we're interested in seeing how it performs in real life. We tested it on the ground, but Orion's going to be coming in faster and hotter than any human-rated spacecraft in history. And so we really want to see how the heat shield performs and make sure all the systems can keep the crew safe for that dynamic event.
So I think it's going to make one curly Q around Earth, shoot off to the moon, make one orbit around the moon, and then head
Our
back.
workforce now is very different from what it was during the Apollo
might make
era.
one or two
when
orbits
Apollo
around
11
Earth
launched,
before
there was only one female engineer in the firing room. Today's launch of Artemis 1 is led by NASA's first ever female launch director. Take a look at how she and other women across NASA are shattering glass ceilings.
When I was a little girl, I wanted to be an astronaut, a scientist, a doctor, a fighter pilot.
When I was a little girl, I wanted to grow up to be strong and independent. When we were asked to draw a picture of what we wanted to be when we grew up, I drew an astronaut standing on the surface of the moon.
All I thought about was when I was going to get to NASA. I mean, I am a fat ass. I would not pass any NASA and or flight training.
To be NASA's first female launch director, to be the launch director for Artemis. NASA has so many wonderful women pioneers, so many heroes to me.
Some of the most amazing women in my eyes are people like Katherine Johnson and the other women that you've seen in Hidden
The
Figures.
ones who did the real programming and math behind all of NASA's
Sometimes
space
it's
launches.
difficult to believe that I'm on this side now, wearing this blue flight suit with all of the other astronauts, representing this iconic image that had so inspired and
If that
excited
didn't say
me my
80s, I don't
entire
know what
life.
does.
Being of South Asian heritage, Kalpana Chawla was just such a big thing for me growing up.
I've always looked up to Sally Ride and Mae Jemison, who really laid the foundation to allow people like me to be in the position that I am
remember
now.
Sally Ride from
All
my
of
childhood.
these women were pushing those boundaries and breaking those glass ceilings.
Now, of course, there are some fantastic women in leadership positions that inspire me every day.
I would
So much
love
has
to
changed
work
since the
for
Apollo
any
program.
space
During the
program.
Apollo 11 launch, we had one woman, one out of 400 engineers in the room. And I look at our team today, it's much more a reflection of the world that we live in.
A big piece of why it's so important to have women and diverse backgrounds, because it allows us to bring everybody along with us on this journey.
It doesn't really matter what you look like. If you've got the brains and you have the knowledge, we need you at the table.
We are at such an exciting time in human spaceflight right now, and Artemis is such a huge part of that.
We haven't been to the moon in many, many years. We have a lot of younger generation folks that have never seen that happen.
We will understand so much more about the moon, about the Earth, about our solar system.
We're going to stay. And to me, that's an amazing idea. The moon is going to be the blueprint for how we go to Mars and out into the solar system and maybe beyond.
I never thought in my lifetime that we would get this close.
Of this Artemis team. It still
I'm
feels
hoping I'm
pretty
alive for when we
surreal
hit Mars
to think that
with
I
people.
might one day walk on the moon.
To see a woman and a person of
land
color
safely
on
on
the
Mars
surface of
with
the
the
moon,
people.
to be able to say that space is for everyone and that we go to space to make life better here on Earth for everyone.
And let's
I
not
know
destroy
the
it like
tears
we've
will
done
be
to our
in my
planet.
eyes.
My message to
Learn
women
from
and
all the
girls out
crap we've
there
done to
is
our
to
planet.
find your passion, whatever that is.
Don't let anyone tell you what you can do or can't do. Only you can realize your dreams.
Space is for everyone. And if me being in this role helps to send that message, I think that's a great thing.
And I just actually love that I don't feel like a woman at NASA. I just feel like a person at NASA.
The women of NASA are Artemis, and we make a difference every day.
I am NASA's Spacewalk Office Hardware Manager. I'm the Program Scientist for Space Biology.
I wonder if
I'm the
spacewalk
Director of NASA's
hardware
Johnson
is like
Space Center.
all the tie-off
I am
points and
I
all
am
the
Artemis.
grapples and the oxygen lines and all that sort of stuff.
Ich bin
I
Artemis.
am Artemis.
I am Artemis.
I just love the way
You
that
got the
video
coolest
ends
job
with
ever.
you and all these
You're on the
other
ISS.
women saying, "I am Artemis." What do you think? Why is it so powerful to just hear those three words, "I am Artemis"? Why does that resonate so much?
I think it just represents how far we've come since the Apollo era and how we take advantage of the incredible diversity our country has to offer. Having seats at the table for everyone, you know, space is for everyone. You heard that a
when
few
was
times in the
suffrage?
video, and I think we're proving that out every single day in our work, not just at NASA, but with our international partners. I think it's so important to our ability to succeed on these really complex missions.
Yeah, I thought that was a very powerful video, and I'm glad that people got that message, young girls in particular.
1919.
Another person who you
That was
saw in that
passed in
video is
1920.
Pam Melroy.
So it's
She's
been
a former
just
astronaut
over
and
100
NASA's
years since women
deputy
even got the right to
administrator. So why
vote
don't we
in
head over to
America,
Jasmine
which is
Hopkins because
fucking
Pam is there with her now.
ridiculous.
Thank
They
you
should
so
have gotten
much,
the right to
Megan.
vote
Yes,
from
I'm
the
honored now
start.
to be joined by Pam Melroy,
100
NASA
years.
Deputy
And look at that.
Administrator.
Now they're
This
leading
is
the
just
teams
a fantastic
for
night. We just saw
space
that powerful
exploration
video with
of the
you
next
among so many
frontier,
of the great women
the
here
final frontier.
at NASA. What is
That's
so
amazing.
important about us now being ready to send, you know, the first woman, the first person of color to the moon?
Yeah, I loved watching that video. Just inspires me. So many of those women
that
are my
translated over
friends,
had
but
black lines
also
going
they're
across my
just
screen.
such fantastic engineers and scientists and just so many roles at the agency. I've always thought one of the strongest teams that you could ever find
She's
is
had
a
some sleepless
family.
nights.
And families have many
What a
women,
stressful
and so
job
our
to be the
teams are
deputy
stronger,
administrator.
I think when we have that balance and that diversity. So that was exciting. But for me, I was a part of the Apollo generation, and I was very
Our bags are
inspired
about as-
by Neil
bigger than
Armstrong,
mine.
Buzz Aldrin,
Yeah.
and Mike Collins on Apollo 11, and all the Apollo astronauts. I just cannot even imagine the inspiration, though, for a little girl. I mean, it never occurred to me that I wanted to be an astronaut, but of course there were no women astronauts then. I think what's going to happen now with the Artemis generation is that first woman and the first person of color is just going to have a huge impact on the next generation.
Right, we are just watching with bated breath, and I know that it's going to mean so much to little kids to look up to them. And we understand, too, this is a huge, I mean, when we launch Artemis, it's going to be a global accomplishment. We have the Artemis Accords, which are helping us make sure we explore peacefully. Can you tell us more about those?
Yeah, it's really important, actually, especially because You know, unlike in Apollo where it was actually just a few countries that had the capability to go to space, now those capabilities are proliferating throughout the world. And so what we do with the rocket is really important.
Sleepy, y'all. Watch this thing. I want to see it go.
And how we go is as teams and with our partners and with a sense of the responsibility that we have as we go out into the solar system to do it peacefully, for scientific purposes, and responsibly.
Right. Tam, you have a great sense of teamwork, and this is definitely not our first time. You know, there's a lot of things that go into testing out a first-time vehicle. There's actually dynamic activity going on right now. So how does this first flight test of SLS compare to other first times? You know, with Shuttle
I can't
and
imagine
Saturn V
the amount of.
Well, I can do even better as a
when we
test
put a new
pilot.
system in at my job,
right? So
it's nothing. Like, you know, 5-6 hours of testing, whatnot. It's good to go. Let it go. Night shift, day shift, we'll fix it.
You actually
the engineers just kind of turn it right over, no big deal.
Run
we
down the runway and come
stuff
back and check all the data
on the fly.
And then you might take off once and go around
this is not only safety concerns for everyone that's
like
there,
taking off and going to fly
but for the next mission when
on
it's
the very
manned,
first flight of an aircraft.
And like
so,
every little detail, there's so many pieces to that puzzle that you have to make sure work flawlessly the first time and every time.
Where, you know, it's not just about learning
what
the
a lot of
hardware,
QA has to go into that.
But it's also about gelling that team together and your procedures and how you're going to deal with issues that come up. Because they will come up. They always come up.
Exactly.
I mean,
and you have that experience
that's
as
a
a
big
test pilot,
ship.
but also as a former astronaut in that
Did
video
you see how
we saw
small
you,
that rocket was
your
compared to that
induction
one?
into the Astronaut Hall of Fame, which is pretty cool. So what is your perspective, or what advice do you have for the Artemis astronauts, those ones that are going to maybe set foot on the moon?
Oh, well, they don't need my advice. I'd love to elbow them out of the way and go to the moon too. They are
Give me a chance.
fantastic. I mean, I'm so proud of all of our astronauts. I was just talking to Jessica Watkins, who just came back on Crew 4. This generation is prepared, ready, and excited. And I think they're really excited that we're putting science front and center in the Artemis program too. We're going to learn so much about the solar system from the moon and even about the Earth. And so I think the astronauts are really excited about doing that hands-on science, and they are ready to go.
Right, I know they're ready to go.
We've got to do another video on all the pictures that have come back from the JWST. I've neglected that recently.
So much. What do you think about this forward movement that we're making right now?
Well, it's really important. This is the Artemis campaign is actually
one of my cats just like knocked over a bunch of my books.
Multi-decade effort that we're doing right now, which is really with the goal of creating a blueprint for how we're going to explore with humans and do science throughout the solar system.
Yes,
so we're going to learn through the Artemis campaign on the moon, and then we're going to go demonstrate it on Mars.
I want to see the dark side of the moon.
The next destination, who knows where.
That's going to be awesome.
I mean, we're going so much further than we ever have
Once
before.
we're stationed there,
Melroy, thank you so much for joining us.
we'll be able to travel more.
Thank you. Go Artemis.
Of course, go Artemis.
Go
Megan,
Artemis.
Back to you.
Thank you both for that interview. Now, teams over at NASA's Johnson Space Center are also monitoring today's launch attempt. So why don't we go back over there with Leah to tell us what's going on over there.
Thanks, Megan. And you're right. Teams here in Mission Control Houston continue to monitor today's events. Again, they will really kick into action once we have liftoff, and they'll remain on console all the way through splashdown. But quickly, I have to show you something, a little show and tell. It makes me feel like the coolest kid. In school, I've got a moon rock here. I hope you can get a good shot of it. It is from Apollo 15, 1971. And when it was brought back to Earth, it was part of a larger rock. In total, it was 21 pounds. This is, of course, a smaller section of that. But we're looking forward to the Artemis program and being able to go back to the moon so that we can continue to gather these kinds of samples, but this time at the lunar South Pole. We've never been there, and we've never brought samples back from that area. So we're really excited to see what might differ in those samples and the ones that we have
display it in a prism.
Now, of course, we've got a whole laboratory of scientists that are able to study all of those samples. We just opened some up for the first time earlier this year so that we're able to test with new technology everything that we can learn about these samples that we brought back now 50 years ago. So hopefully within the next few years, we're bringing some new ones back to use that same experimental process on and tell us a little bit more about the moon. But just had to show this
Look how
off.
excited
Apollo
she is.
15
I
moon
love
rock.
it.
We're looking forward to having some Artemis ones here at Johnson Space Center. With that, I will send it back to you at KSC.
You were a cool kid before you even had the moon rock, so. But now you're even a cooler kid. Now, the name Artemis was chosen because in Greek mythology, she's the twin sister of Apollo. NASA's Leo Martin is over at the nearby Kennedy Space Center Visitor Complex, where thousands have gathered to watch today's launch attempt.
Hi,
we got
Megan.
the frat boys.
I'm actually joined here tonight by
The
a
redneck
very
frat boys.
special group of guests here from Stennis visiting Kennedy Space Center. Why don't you tell me, Ryan, what it is that ties you to tonight's launch?
So we were lucky and privileged enough to be able to test the core stage of the SLS rocket that's going to launch today. We got to green run, which is a full duration.
When she
hot
said
fire.
Stennis, I was thinking the Navy?
It's a very historic time for us at Stennis. It was so exciting to be a part of. It was 7 years of hard work by a lot of really great people.
And Jack, sorry about
just so excited to be here to see it.
And Jack, you were actually telling me that you know firsthand, how much work has gone into tonight's launch. What does it feel like to be here tonight, seeing the rocket fully integrated on the pad, ready to go?
Man, I'm just incredibly grateful to be a part of this history and just really excited to see this thing launch.
Stennis, Texas? Is
And
that where the
Barry,
rocket
you
testing
were
is?
telling me that you know also
Where's
firsthand, the adversity that these teams have overcome to be here tonight. Do you have a word of encouragement, anything that you'd like to say to the teams all across the United States right now, both at Kennedy and at JSC,
Mississippi.
who are just sitting in the seats ready
Duh,
to
that
get the
makes
rocket
sense.
launched tonight?
Sure, persevere. I mean, it's hard work, but it's so well worth it. We spent many hours doing the testing and trying to get ready for this moment, and I think we've forwarded that information
So I'm assuming
to
they
those
do both
guys, and we also
non-destructive
give them the
and
encouragement
destructive
to continue on,
testing
so we know they can do it.
on the rockets?
Thanks so much, Barry. And I think it would be great if, just on the count of three, we can give them a great big go Artemis. 1, 2, 3.
Go Artemis!
Back to you, Megan.
Poor guy on the end didn't get to
That
talk.
was amazing. And that's just, people who were actually able to come here to Florida. There's many people who are joining us from around the world who couldn't obviously make the trip out here. So let's take a look at some of those watch parties there. Here's Space Center Houston. It's the visitor center over for Johnson Space Center in Houston. And you can see a lot of people there after hours because that visitor center is closed right now. People are waving.
Man,
I love
they're
it.
having
Wow,
a
look
party.
at that. Whatever that is,
That's
it's
awesome.
amazing.
I don't think I've ever noticed that when I'm at Space Center Houston. Maybe it's new.
I know.
Yeah, what the heck is going on here? I want one of those in my room.
Again,
right there.
All
To
these
get rid of
people
that
who are
light.
Captivated,
That's
young and
freaking
old,
cool.
by today's launch attempt and the beginning of the Artemis program. I know that they're probably looking at the clock and wondering when we might see the launch today.
When can I go home and go to
lovely
bed?
see all those people.
And there's the Space and Rocket Center, where we have a ton of people waving
cheerleaders.
flags,
Excited.
cheering us on tonight for this incredible launch this evening.
I love that. They totally look like cheerleaders, and they're embracing it. I love it. And yeah, this is the U.S. Space and Rocket Center. This is the Visitor Center over in Huntsville, Alabama. As I've said before, Marshall Space Flight Center there is super instrumental in what the Artemis program is doing.
The refined
They,
Germans just sitting quietly
contributed
waiting.
a lot to the mission, so it's nice to see everyone there.
Why did I have
and
a
then
slightly
here is
British accent
Airbus
for
in
that?
Bremen,
The
Germany.
Germans
so
are
Airbus is the
waiting.
main contractor for the European Space Agency, and together the company and ESA, they provided the European Service Module, which is an important
see no
part
bow
of the
ties.
Orion spacecraft.
Nobody has a bow
So
tie.
we have
Not very
quite a bit of
refined.
people there. A more reasonable time over there in Germany. It is 7 a.m.
More reasonable time,
so
she
I'm
says.
going to say Guten Morgen to them. Did I say it right? Guten Morgen to
morning.
them over there in Bremen, Germany. Again, the Airbus company. All right, so let's get another check on the launch team with our Daryl Nail, who's inside
Yes,
there.
please
and have an
check so I
update
can
for
go
us.
to sleep.
Yeah, that's right, Megan. So we are clearly in a
It's hard to
delay
be
now.
both
The NASA
sleepy
test
and excited
director,
at the
who's
same
basically
time.
flying the ship
I should have saved my
for the
energy
launch
drink till
countdown
now.
tonight, has said that we are extending the hold that we were currently in at T-minus 10 minutes and counting. And so that puts us off the 1:04 a.m. Eastern Time launch. We're now slipping indefinitely
17
into
minutes
the
so
hold.
far.
NASA test director Carlos Monge saying that we are currently estimating how much work needs to be done before resuming the polling that is supposed to take place 15 minutes before launch. It then goes to terminal count at T-minus 10 minutes. Now we've got an update on the tanking of the upper stage liquid hydrogen tank. Currently 95% filled. We're in topping on that tank. It is the last of 4 tanks in the Space Launch System that needed to be completely fueled up before we launch. Of course, cryogenic tanking, a complex operation that has seen some delays tonight. We had a roughly hour delay after a replenish valve on the core stage liquid hydrogen side required hands-on work by a red crew team.
It must be
that went out to the
nerve-wracking
launch pad
for people who are actually getting ready to launch into space to be sitting on top of that while that thing is getting filled with more than half a million
verifying that work
gallons
was complete
of fuel.
Now currently we're awaiting some work with
that
the
makes
range.
me anxious just thinking about it. I'm sitting in a
space wing, which
nice comfy
oversees
chair.
the range here, and make sure that the airspace and the ocean out over the flight path is clear, and also has the responsibility to destruct the rocket should it go off track. They have been working on some issues with their equipment.
They showed it in
sending a flight
couple other
termination
videos I
signal
watched
to the
on
rocket. There is testing that must happen with the flight termination system that was delayed by a bad Ethernet switch. Switch has been changed out, and now the range is looking to start testing their connectivity to the rocket in order to preserve that safety function that they are responsible for. So again, we are slipping now indefinitely into the launch window. We're awaiting the launch team to evaluate just how much time is required to complete the work to get this rocket ready to launch. And of course, when we have a new T0 for you, we'll report that out right away. Megan, back to you.
Daryl, thank you so much. As NASA prepares to explore the moon, here's a look at the spacesuits and tools that will help us to do that.
Watching Apollo footage of astronauts doing geology on the surface of the moon is a really great way to think about preparing for Artemis, for putting people on the lunar surface once again. We learn a lot in how they did science operations on the moon and what it's like to work on the moon. You see them doing geology. You see them taking rock samples, putting in a drive tube to take a core sample. You see them bouncing along the surface of the moon on the lunar rover.
Image taken with my cell phone through the eyepiece of my new telescope. I'm so excited. I mean,
the next generation of spacesuits and geology sampling tools.
We're gonna be.
These
I'm so excited.
Help us train like we are on the lunar surface. You know, these 1.6G offload systems for putting people in the aquatic environment are great ways to train the mobility part, right? Like what can you do and how different does it feel to be in 1.6G and do these tasks?
We've been training astronauts in geology and geoscience for decades now. The Apollo astronauts
That's going to be a really cool part too, is if we send the right equipment up, we'll be able to do all of our geological testing
it's often said
on the
that
moon,
Apollo
instead of having to send it all the way back to Earth to do the
degree
testing.
in geology by the time they flew to the moon. In the intervening decades since Apollo, we've been training astronauts who fly to the International Space Station because when they're on the ISS, they spend time observing the Earth, looking out the window, taking pictures of what they see on the Earth's surface. Now that we're looking at putting astronauts on the surface of the moon, we also take them into the field. We take them to field sites here on Earth that resemble field sites that we expect them to see on the moon.
That's the reason why we take them out into places that are unique like volcanic landscapes or places that are analogous to the lunar surface to train them on the scale and fidelity of science that you just can't recreate in these facilities.
And so by combining this classroom and field training, we're able to prep them for fundamentals of geology, the major driving lunar science questions that we have that we hope to address with the Artemis program, and teaching them how to do field work in relevant analog environments.
For just science aspects of developing new spacesuits, can it get you to where you need to go? And then once you get there, can you do the cool science that you need to do? And so that's, can you move effectively and efficiently in the suit to be able to collect the samples or use the tools or the instruments? For the visibility, it's like, can you make the necessary observations that you need to? Or does the suit have the lights on it that it needs to illuminate the surface and make the observations you need to? The lunar South Pole holds tremendous resources that are going to allow us to continue to explore. This is a place that we've never been before. There's so much to be learned from getting boots on the ground and exploring a unique place that challenges us as humans and also helps us develop technologies that make our everyday life that much better.
We think there might be volatiles present at the South Pole.
I'd
By
get
using
motion
these
sickness,
volatiles,
but
we'll
man,
be
if I
able to
could
do
go, I
things
would
like
go.
create drinking water, create rocket fuel to launch astronauts back to Earth. And so by harnessing the power of the land, we'll be able to help astronauts establish that long-term sustainable presence.
It's human nature to explore. Pushing our boundaries and exploring our universe is, I think, just one of those things that's just stuck in our human nature, and that we need to do it in order to understand the world around us, including our Earth and our solar system.
We just heard there how curiosity is just a part of us. So, with that in mind, why don't we do some social questions? Because some people are very curious to hear what you have to say about their questions. So why don't we pull up the first question here? What are your thoughts on the responsibilities that come with going to space? Obviously a question for you. I am not going to space.
Yeah, the opportunity to travel to space comes with a lot of responsibility. I think for all of us, it's a huge honor to be a part of these teams, and the work we're doing is so critical in supporting scientific discovery on the ground. So on the International Space Station, we're a national laboratory. Our crew executed over 350 different scientific experiments during our 6-month mission. And so when you think about that, it's years of work to get one of these payloads or an experiment on the space station. Yes. And sometimes that's someone's life's work you're holding in your hands and executing. And so being prepared for those moments is really important, and understanding how to bring the team from the ground into solving complex problems. We take that really seriously.
Look at that.
And of course, we want to share what that experience is like. Only a few people have been able to go to
space.
And as we commercialize space, as low Earth orbit becomes more accessible, that'll change. But still,
that we
it's
have
available
up there.
To some of us, so we really want to share what that's
ridiculous.
like.
We've already littered space around our atmosphere.
It's really great to see and hear that you guys acknowledge that, right? Like that this experiment that you're holding, that you're working on for 6 months, somebody has been working on literally for years. I mean, I've talked to some scientists, and they're saying, "Oh, this has been my life's work, 20 years of my life's work." So yeah, that was a really good question. I like that question a lot. Okay, we have another one from social media here. Astro Kayla, have you considered what you might say if you had the opportunity to be the first female to set foot on the moon surface?
Space Force.
No, I have not considered
It's good to be black on the moon. Isn't that what she said in that show?
That role, it's something
I think that's what she said.
Really seriously, I think the iconic words of Neil Armstrong, one small step for man, one giant leap for mankind, are something that we all know, whether you witnessed that moment or not, or it happened before you were born. For me, I think we all have that embedded in our psyche, those important words. So I think it's something I would have to think a lot about ahead of that mission.
Yeah, that would be in the history books. That'll be something you're remembered
Don't let me
for.
speak.
Oh my gosh, I'd be so anxious delivering it, even after I've thought of what I want to say, like to actually open my mouth and say it from the surface of the moon. Wow. Yeah.
Well, not to mention, you'd be so enthralled with just being on the moon.
Okay,
my brain would just be like, I can't speak. I'm in awe.
That's an awesome question that I wish I knew the answer to. Megan and I were actually talking about that earlier when we had Snoopy up here. It's a continuation of the same suit that we used during the shuttle era, and I was kind of hypothesizing that maybe it's to help forces if for some reason when we landed in the water we had to get out of the capsule for some reason, it would be easy to see us. But that I'm gonna have to take a phone a friend on that one, I think, to know the real answer. I'm sure somebody will be commenting on social media right now with what the real history behind the orange suit is.
I'm trying to think about it too. I'm thinking, does it have anything to do with SLS being orange because of the foam
match your
insulation?
vehicle.
Yeah,
Why not?
maybe it's that.
I don't know.
I don't know. We got stumped. That was our first one that we got stumped on. Do we have another question? All right, if you could name one of the moon's craters,
international orange color
what would you
instead
name
of silver
it?
white as it previously did. Blah blah
What would
blah.
you name it, Megan? I
The
don't
orange
know.
color
That's a big
allows
decision.
rescue
I
units
thought
to
you
easily
might
spot the
say
astronauts
the
in
name
case
of
of
your
an over
zero-G
bailout over the
crash.
ocean.
Oh,
she was
wow.
100% right.
Yeah, maybe. I don't know.
So it's the international
That's a,
orange
pretty
color.
Big responsibility,
But
I
yeah,
think,
she
to
was
name
absolutely
these
100%
geological
right
features.
that it was
And
because
a
of
lot of the
when they
craters on
land.
the moon already have names. So
Yeah.
I'm sure there's some that maybe they haven't named, they're too small, or we haven't explored them yet, but a lot of them already do have names. Like we're going to be exploring the edge of Shackleton Crater as part of Artemis mission. So a lot of them are already named and mapped.
Yeah. Thanks for throwing it back on me. I was like, I don't know. Do you think like our parents or husband or fiance are now upset that we didn't say them?
I don't know. I mean, I don't think so. I think they understand.
All right.
These are big decisions.
This is. All right, last question here, for this segment at least. What will Orion do when it gets to the moon?
So for this mission, Artemis 1, it's actually going to
Big
orbit
yawn.
the moon and then go into a distant retrograde orbit. And so it'll get really close as 62 miles, and then go way past the moon and way deeper into space than we've ever been before. So yeah, the Orion vehicle will be checking out all of its systems. We're going to be analyzing that data from the ground, and then we're going to see that it can survive re-entry and a successful splashdown off the coast of San Diego.
Yeah, that was a good question too. Okay, well again, just keep those questions coming. You know, we're entering into this launch window.
Not only is it going to the moon, it's also crossing
America. We'd love
America.
to hear from you, and we'd love to try at least to answer most of your questions. So you've been hearing throughout the broadcast all the different science that returning to the moon will enable us
Now
to
let's
do.
hear
So there's
that
actually
we're going
something
for
called
launch
the Prime
soon.
1
Come on.
mining experiment, and that's going to robotically look for ice and other resources below the lunar surface.
I wonder what all is involved with the range testing for that.
NASA's first polar resources ice mining experiment, also known as Prime 1, will robotically look for ice and other resources below the lunar surface. Thanks to data from spacecraft orbiting the moon, scientists believe that the polar regions contain water ice in the form of ice just below the surface. With the right technologies, that ice is a game-changing resource that can be mined and used to produce propellant and breathable oxygen for future explorers. Under NASA's Commercial Lunar Payload Services Initiative, the agency selected intuitive machines to fly and land Prime 1 on the moon's south pole. Prime 1 will land near the Shackleton Crater to drill into the lunar soil in an area that could contain water ice. Prime 1 is made up of two instruments,
Over
Trident,
200,000
the regolith and
kilometers,
ice drill
and it
for
can
exploring
land
new terrain,
exactly where it
and
needs to.
M-Solo, the mass
Right,
spectrometer
I
observing
should know
lunar
this. This is
operations.
one of those things I should know. How far is the moon away?
Trident will drill up to 3 feet into the lunar surface, extract lunar soil, and bring it up to the surface. Trident drills to its maximum depth in
miles,
multiple
not kilometers,
phases,
miles.
stopping at different increments.
Miles.
As it reaches each desired depth, it will pause and retract the drill string to deposit lunar soil on the surface for analysis.
This is the time of year when things get
This is
stale
where
in
M-Solo
Tennessee
comes
inside
in.
houses.
M-Solo is a commercial off-the-shelf mass spectrometer modified for spaceflight. It will evaluate the chemical elements and compounds released from the lunar soil for water and other chemical compounds.
Off the shelf, and it's going to space.
Trident will then proceed to
Way
the
to
next
upgrade yourself, mass
specified
spectrometer.
depth and repeat the process until samples at all desired depths have been analyzed for
I
water.
want an off-the-shelf
If
mass
no ice
spectrometer.
is found where Prime 1 lands, NASA will still collect valuable information about drilling into the lunar soil for a future mission. NASA's Viper, the volatiles investigating polar exploration rover, will use Prime 1 technology on a mobile robot that will navigate the moon's
They're only anywhere from
South Pole,
$518 to
resources.
$33,000.
Prime 1 data will help NASA assess lunar resources to inform future Artemis missions and a robust human presence on the moon.
Like, can I just buy? I can buy them on eBay.
So we are still awaiting a new T0 for today's launch attempt, but for more on what to expect when we launch for this first day, let's go to NASA's
just buy a mass spectrometer. Don't know what I'd need it for.
Saturn V Center at the KSC Visitor Complex.
Hey, thanks, Megan. Everybody, welcome back to the moon board. There's a lot of people here in the complex. I just heard a woo-hoo. People are getting in and out because we have a great view of launch when it's going to happen, and it's going to happen today. But that launch is just the first step in the Artemis 1 mission. So let's look at what's ahead for this historic first flight. As we just said, launch is step number 1. Those 4 RS-25 engines throttle up, followed shortly after by the 2 solid rocket boosters igniting, sending SLS and Orion skyward. Now, on our way uphill, we'll have a number of jettison events. You'll be able to see things coming off of the SLS rocket. One of the most visual ones will be these 2 solid rocket boosters. Now, they'll expend their propellant a little over 2 minutes into the flight. They will separate. We'll see them flare off onto either side, and then the core stage continues to fire. We're also going to see the launch abort system come off the top. Once you get high enough in the atmosphere, it's no longer required. You could actually do aborts using engines on Orion and its service module. I will also note that on the launch abort system, it's got those 3 solid rocket motors. The jettison motor is active. The abort and the attitude ones are not for this flight. We don't have people, so we're not flying a fully active abort system. We also have 3 fairings that are there to protect Orion, the service module and the crew module, as we're flying up through the really dense parts of the Earth's atmosphere. Next up, we'll hit core stage separation. So we've got 4 main engines. We'll hear MECO, main engine cutoff. Those engines will shut down, the core stage will separate, drop away. It's eventually going to splash down in the ocean. And that hands over the propulsion duties to this, our upper stage, the interim cryogenic propulsion stage, or ICPS. Its first job is to execute what's known as a perigee raise maneuver. So the perigee is the lowest part of your orbit. You have a perigee, that's your low part, and an apogee, that's your highest point. We're going to raise up the perigee, and that's going to actually put us in a nice circular path around the planet. And while we're there, that gives us time to check out Orion. We're flying it in space for the second time, the first time in this fully integrated stack with SLS.
You gonna come watch the
we'll
NASA
be able
launch
to look
with
at
me?
all of Orion's systems.
Don't knock over the Hubble,
make sure
dude.
Those solar arrays are capturing the sun's energy and turning it into electrical power for Orion's systems. Make sure the communications are working, all of our guidance, navigation, and control. That is your time to make sure you have a healthy spacecraft before you do something that is going to send it to the moon. And that's next up on our list. That's the trans-lunar injection. For today's launch profile, that's going to be a firing of about 18 minutes of that single engine on the upper stage. Now, that engine optimized for a vacuum. It's producing about 24,000 pounds of thrust. So it's a pretty big engine, and it's doing that because we need enough energy to be able to send our payload, Orion, beyond low Earth orbit and send it on a path to head out to the moon. Now, after that burn is complete, ICPS separates. It's going to do what's called a disposal burn. So it's going to send itself on a path from Earth around the moon and slingshot out into what's known as a heliocentric orbit. So it's going to completely leave the Earth-Moon system and go into orbit around our sun. But after it separates, propulsion duties get handed over to this, the European Service Module. And it's got a couple of different engines that it's going to be using, and we're going to be testing those out just on day 1. We're going to do what's called the Outbound Trajectory Correction Burn 1. And we'll do a couple of these trajectory corrections as we're flying out to the moon, but that first one is that first critical test of this large engine, the Orbital Maneuvering System engine. That's the one that has the most thrust, generating about 6,000 pounds of force in a vacuum, and that's what's going to be doing a lot of our maneuvers or giving us that pushing power as we do these maneuvers around the moon to enter into what's known as distant retrograde orbit, or DRO. And that's this dotted line that you see around here.
Well, we should be
now,
able
we
to get
call it
pictures of
distant
quite a bit of
basically
the moon.
because of the distance we're away from the moon. We're about 40,000 miles, a little bit less, off the lunar surface. And then we call it retrograde because the moon orbiting planet Earth in this direction, going in a counterclockwise fashion, we're going to be entering into a clockwise orbit around the moon, opposite retrograde. Now, to do that, we're going to get in close. We're going to dip in off the lunar surface. We're going to be about 80 miles, 80 statute miles off the lunar surface as we do this outbound powered flyby. Again, the major thrust coming from that orbital maneuvering system engine. After we do that, we'll do a final maneuver to actually go into that distant retrograde orbit, that DRO. Now, why DRO? Why are we not just going around the moon and coming back on like a free return trajectory, which we did on some of the Apollo missions? Well, in DRO, it's a very stable orbit. It doesn't require a lot of fuel to maintain that area around the moon. So it gives you a lot of time to really test the spacecraft. If you followed with any launch of a new spacecraft, you know there's only so much testing you can do on the ground. Once you actually put all of that hardware in space, in the environment that it's going to be operating, hundreds of thousands of miles away from Earth, you're going to learn things you didn't even realize about everything from communications, the life support systems, the thermal control. Everything on a spacecraft needs to get put through its paces in this environment before we put people on board, and that's why we're heading out to DRO. Eventually, though, it's going to be time to come home, and we will do a DRO departure maneuver. This, again, firing up that orbital maneuvering system engine and others on the service module, and this is what's going to commit us from leaving the moon and heading on back towards Earth. We'll dip in once more, close off the lunar surface, slingshot and use the lunar gravity to do this return-powered flyby, and then, similar to the way out, we can make correction burns as we kind of fine-tune our path back towards the Earth. And then it's time for re-entry. A couple of things happen before that. One of the really critical ones, spacecraft separation. We're going to detach the European service module shortly before re-entry. Its job largely done. That burns up in the Earth's atmosphere and reveals on the crew module
Don't break
the heat
Discovery,
shield.
dude.
I circled it earlier. This is goal number 1 of the Artemis mission. Artemis 1 mission
make
is
sure they
testing
can
this
get back
heat
in.
shield at lunar return velocities, because when we make that trip around the moon and we come back, we are going in speeds of excess of 20,000 miles an hour.
Good
So when we slam
Lord.
into the Earth's atmosphere, it's going to heat that thing up to more than 5,000 degrees Fahrenheit. For the Artemis 1 profile, we're going to do what's known as a skip re-entry. So basically, you can come in too shallow and skip off the atmosphere, too narrow, and you're going to do what's known as a ballistic entry, which really heats things up. We're going to do kind of a mix where we're going to skip once off the atmosphere, and that we're still going to get the heat, but that helps to reduce some of the G loads on the crew. Once you're through that, you get to parachute deploy. There's 11 parachutes in total that are going to slow Orion down before it splashes down.
20,000 miles an hour
to about 300 miles an hour before those parachutes deploy, and then they do a final job
in a matter of
getting it in the
70
water in the South
miles.
Pacific. We've got these big
what
orange
a
balloons.
slowdown.
That's an uprighting system, so even if Orion landed in the water upside down, those can inflate, and they put us back upright into what's known as stable 1. That's where you want your spacecraft to be, nice and upright in the water, especially if you're an astronaut in there floating. Now, we also have a large U.S. Navy ship with a big bay that's going to basically come up and swallow Orion into its deck.
That's cool.
And you've got a couple of other assets in the area to help recover hardware, the forward bay cover,
And that's if we actually
parachutes,
make
things
it
like
to
that.
where we say
But
we're going to
that's
land.
scheduled to happen 26 days after a launch today. So that's 26 days from liftoff here in Florida, around the moon, to a splashdown in the Pacific, and that will be the first mission in the Artemis program, the farthest we've ever sent a human-rated spacecraft in history, and just the first step before we put people on board. So that's a look at everything
satellites
still to
a lot
come.
farther.
We're counting down to that launch. I'll send it back over to Megan
and
the
helicopters
team at the host desk, guys.
A very comprehensive look at that. Thank you so much, Dan.
That was really cool.
If you're just joining us, welcome to Kennedy Space Center and our live coverage of Artemis 1, an uncrewed flight test that will return us to the moon in nearly 50 years. But, you know, some might ask, why the moon? Well, here's why.
Hubble, come back.
Are going.
Yes, we are.
The history of this agency is marked with broken barriers, once viewed as impossible, with science fiction turned reality, with innovations that have spun industries all their own, and with demonstrations of peace for all humankind.
That have recently been broken thanks
of
to
our home planet.
wars going on.
We maintain a human
politics and
presence just outside of gravity, and we touch points all across the solar system and beyond. We're going back to the moon, and this is why.
The moon is a treasure trove of science. It holds opportunities for us to make discoveries about our home planet, about our sun, and about our solar system.
The wealth of knowledge to be gleaned from the moon will inspire a new generation of thought and action.
Without fail, every major program and mission NASA has invested in has led to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and the generations to follow.
The tens of thousands of jobs associated with propelling us to the moon today are just the beginning of a lunar economy that will see hundreds of thousands of new jobs develop around the world.
Not worried about the jobs,
an ambition of one entity or one country.
Humanity.
The exploration of the moon is a shared
further into the future.
Woven together by
Jobs
a
come with that.
for the greater good.
Why the moon?
We should be living in a resource-based
because the missions
economy
of
anyway.
tomorrow will be sparked by the accomplishments of the Artemis generation today.
Because the ambition to go has already begun.
And because Mars is calling. We need to learn what it takes to establish a community on another cosmic shore. So let's camp close before pushing out.
And so, we go to the moon now, not as a series of isolated missions, but to build a community on and around the moon.
Being part of the first crew to live on the moon.
On other worlds.
How strange.
We'll use the lessons from more than 50 years of peaceful exploration to send a new generation to the lunar surface to stay.
We will anchor our efforts on the lunar South Pole to establish the Artemis Base Camp, positioning us for long-term science and exploration of the lunar surface.
We will prove what it takes to assemble a complex ship in deep space.
We will perfect descending down to and returning from a distant surface.
We will learn how humans can survive and thrive in a partial gravity environment.
With improved spacesuit designs, mobile habitats,
and radiation.
and
Don't forget, we got to deal with the radiation.
Relocating supplies.
We will learn
extreme heat, extreme cold.
Find on other worlds, starting with finding water ice and purifying it to drinkable water.
And refining that into hydrogen for fuel and oxygen to breathe.
We will establish fission power plants on the surface of the moon, capable of supporting a growing community of efforts. And we will expand the logistics supply chain to enable commercial and international partners
To resupply and refuel deep space outposts.
None of this is simple or easy.
That's an understatement.
But nothing in our history ever has been.
The Eagle has landed. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
This kind of continuous lunar presence is a natural extension of all that we've learned in low Earth orbit.
My mouse and keyboard
And
are
what
here
we will accomplish
in front of the
there
Legos.
will ensure the monumental missions to Mars are within reach. As we ready the launch of the first Artemis mission, and as commercial companies ready their lunar landers for the first private payload deliveries, we have already begun to take the next step.
Throughout throughout this launch broadcast, our NASA's Leah Martin has been introducing us to people over at the Kennedy Space Center Visitor Complex who have come out for hopefully the maiden voyage of Artemis 1.
Hopefully,
people from near and far, young and old, just really excited to hopefully see this historic flight. So now she's joined by somebody else who has a really interesting story. Leah, tell us about it.
Megan, I think one of the most exciting things about being here tonight is being with people who are like-minded, who have such a strong tie to the history of our nation's space program and their love of spaceflight. And I actually struck up an amazing conversation with Scott here, and you were telling me about the special tie that you have to tonight's launch as well.
Oh yeah, I literally grew up with NASA. My father went to work with the NACA before NASA. Went to work for Dr. von Braun, followed him over to Marshall Space Flight Center, and became, when it became NASA. He worked on the Jupiter C, Redstone, Saturn I, Saturn V, and then because of that, he brought me here to see Apollo 11 launch. So that was my first launch. I was 5 years old. I loved it. Still remember the sound. That's about all. And then years later, through my flying career, I was able to bring my sons back with my friends that flew the shuttle, and they saw 5 launches and 4 landings. But basically, I wanted to be here. I was here for the first moon launch, the last moon launch back when Uncle Gene Cernan, our family friend, went to on Apollo 17. So I wanted to be here for this because it's kind of in our family, in our blood. And hopefully I'll be around for the next one when we go and land again. So that's
incredible. So you have NASA actually in your DNA, grew up with the program.
Yeah. I knew most of the German scientists. The kids sat in our lap, Dr. Ernst Strelinger, and my father flew with von Braun because he was a general aviation pilot as well. So they'd get off work and fly. And they were in Life magazine together, National Geographic. So it was fun. I literally knew Al Shepard, all the Mercury, Gemini, Apollo guys, and it was an honor. I would have loved to have been an astronaut, but I went a different route, and but I can still come here and see them.
We can, and we're so grateful, so thrilled to see you here tonight, and so excited that you will be able to actually compare the last launch and the sound of the last one with the one tonight. It's absolutely going to rock the sky.
This thing is going to be loud.
I want to feel it. Yeah.
Well, thanks so much for joining us tonight. It's been an honor to meet you, and Megan, we're going back to you.
Leah, thank you so much for sharing that. That was such a fun story.
Launch.
Here we are now at Space Center Houston. This is a live look inside of the visitor center there. Lots of people hoping to see the launch today. I love this guy in the front with his NASA shirt representing. And again, just seeing children and young and old, just all these people who feel captivated and are excited about our next giant leap into deep space. So glad to have them here. Oh my gosh, I love this.
Still rocking.
Yeah.
Good Lord, how are you guys still full of energy?
Always ready for their
I love the inflatable in the background. I want one of those.
That's the home to the SLS program office, so they have a dog in the fight tonight, seeing Artemis launch for the first time.
Is that an inflatable astronaut in the center? Do you see that? I think somebody is dressed up as an astronaut.
Look at that.
Yeah,
they're
representing.
Ready to go.
I love this. Yeah, I'm so glad that they're there. Again, these visitor centers are closed to the public, but the people there decided to hold a watch party, and
look,
that's
our
exciting
friends
to
in
see.
Germany are ready for us this time. They anticipated the delay. They look pumped and ready to go.
So these are employees of Airbus.
They were just
Airbus
relaxing,
is
getting ready.
Main contractor for the European Space
Maybe they know
Agency,
something we
and
don't
together
know.
they provided the European service module for the Orion spacecraft. So really, we should be applauding them. They shouldn't be applauding. Thank you so much, guys, for your contribution to the program, and can't wait to see Orion.
Ich bin ein Berliner.
Okay, so now let's head back over to Daryl Nail over with the launch team so we can hear any updates about
update us.
Yeah, Megan, thank you. And a clearer picture is starting to emerge as the launch team now reports out that they only have a few minutes left of work to do before they're ready to pick up polling. And we're also hearing that some of that polling, which kicks off with the mission management team, is also now just about 3.5 minutes away. Now, we are currently still in that hold. But the launch team, NASA's test director, is continuing to move the team forward. We've wrapped up work on the upper stage and the lower stage. You're looking now live inside firing room 1, where launch director Charlie Blackwell Thompson
he's talking about that.
Overseeing
Polling's going to be soon. I'm going to go get a couple drinks to
We've
prepare.
had a number of delays that have put us off the T0, but we are starting to track to a T0 close to around a quarter till, top of the hour. But we do need to have some polling that takes place. I'm pausing now because I'm listening in to the teams as they communicate. In this launch window, which we're currently 26 minutes into, and it's 2 hours long, it runs until 3:04 a.m. Eastern Time. We have what's called 40 cutouts. And in those cutouts, they range from about a second to about a minute. These are times where they can't launch. These cutouts must be accounted for when determining a new T0.
Hey, yo, Beck. What do you say? What'd I miss? I got a drink.
The upper stage of
said, what, 3 or
rocket,
4 a.m.?
which was the last to get ready and configured.
So 2 there, so they got about an hour.
Just recently, the team cycled the liquid hydrogen valves, which is required. And they are currently working on the LO2 valves, liquid oxygen valves in the upper stage. That work is almost done.
Did they say whether we're 100% yet or not? I'm assuming they are, because now it looks like they're venting. How freaking cool. What a cool piece of equipment.
We are now a minute and a half away from the poll of the mission management team, which is several minutes before T-minus 15 minutes.
That's all the final checks and making sure everything's ready to go.
When that poll starts, we'll get a clearer picture of our T0.
You got to be stressed, lady. Oh. All those people have to just be full of anxiety and stress. Oh, I can't imagine. I mean, excitement and joy, stress.
The launch team to all switch.
I mean, I'm nervous over here. I'm just
communication
sitting in
channel.
my
It's
nice,
called
comfortable chair.
232. And what this means is that the entire launch team is now on one channel.
Oh, God, guys.
And all
I've almost been up for 24 hours.
Communication will happen there, whereas there are many channels. Now they reduce it down to one. Just heard from NASA test director Carlos Monge.
I broke the Discovery.
I'm sorry, Jeff Spaulding. Jeff Spaulding's on. They swapped out. There are currently no constraints to launch.
Where the hell does this part? Oh, this part goes right
Great
here.
news. Again, no constraints to launch. And
Oh,
they're getting ready to pick up with a poll.
We're getting. Where does this go? I broke the Discovery.
Determine readiness for launch.
Stay. Let's close the shuttle bay. Don't look at me like that, cat. Don't judge me for being a nerd. Oh, it got really quiet all of a sudden. Oh, I'm so excited. Come on. Get the polling started so we can actually hear from the launch team. That's the exciting part, because that means, it's getting serious and ready to go. Those umbilicals, the quick disconnects are just crazy to me. The design on them. After the first hydrogen leak, there was a couple videos
NASA
for the open source.
Test director
Really
Jeff
cool.
Spalding
They're on
getting ready
YouTube.
to conduct the readiness poll, so we are getting close. We're going to pull up the audio now so that you can listen in.
LPs go. And rock. Rockets go. All right, copy all. And Launch Director NTD, our launch team is ready to proceed at this time.
I copy all NTD. At this time, I will proceed with my poll. And attention on 232, this is the Launch Director performing the final poll for launch. Verify no constraints and go for launch. EGS Program Chief Engineer.
EGS Program Chief Engineer verifies that the EGS, SLS, and Orion Program Chief Engineers have no constraints and are go for launch.
Oh,
Copy, Greg. Thank you.
We'll get
EGS
goosebumps.
Chief Safety Officer.
Oh, it's there.
The EGS CSO verifies the SLS, Orion, and EGS CSOs have no constraints and are go for launch.
Copy, John. Thank you.
Get rid of her 15-minute launch window.
Weather has no constraints and weather is go for launch.
God, look at the humidity.
Copy LWO and Mission Manager.
Just
And Mission Manager, Launch Director.
Come on.
Launch Director, Mission Manager on 232. The mission management team has been polled. You have a go to proceed with terminal count and launch of Artemis 1.
I copy all. Thank you. And NTD, Launch Director.
Go ahead, Launch Director.
Yes, sir. On behalf of all the men and women across our great nation who have worked to bring this hardware together to make this day possible, and for the Artemis generation, this is for you. At this time, I give you a go to resume count and launch Artemis 1.
Yeah!
Copy, Launch Director, and thank you.
15 minutes, or are we going T-minus 10 right away?
To configure, and then we will be ready to resume the clock. CVSE, NTD. CVSE here. Initiate recording of Orion cameras at this time. In work. R, NTD. RSR here. Perform the booster ignition SNA arm rotation enable.
NDT, RSR, booster ignition SNA arm and rotation enable is complete.
And I copy. Thank you.
Okay, so there you heard the poll from Launch Director.
Early.
Getting ready to get that new T0 time.
He's trying to keep quiet so he can hear what launch control is saying.
The poll that you heard was the NASA test director's poll. And
all right, and we have verified no cutouts at this time. And all personnel, we are going to resume the clock. GLS, you can resume the clock on your mark.
GLS copies. Countdown clock will resume on my mark. 3, 2, 1, mark. GLS mainline has been initiated.
Okay.
T-minus 10 minutes and counting.
T-minus 10 minutes away from liftoff of Artemis 1. As you can see, the clock is now moving. Let's put that up. T-minus 9 minutes and 47 seconds. The L-minus 15 poll complete.
Show 06:47:44 is the new liftoff time.
Affirm.
Okay.
47:44.
01:47:44. 1:47 a.m. Eastern Time and 44 seconds.
That's it's 1:04.
We went straight into
which
terminal
would be
count.
2:04. That's the time has already passed.
Liftoff now 9 minutes away.
Oh, come on. This is what it's all about.
Count.
Look at those
Control has
umbilical
been
cords.
given over
I mean, that
to
thing's 200
the GLS,
like
the ground launch
50,
sequencer,
70 feet somewhere around
the
there.
computer and software
Those
that is
things
doing
are
all
like
of the commanding
this big
and
around.
monitoring of the Space Launch System.
Actually, they're probably more like that. They're huge.
We'll hear call-outs from the GLS
I
operator.
think the actual pipe is 8
Alex
inches. But then,
Pandalos.
of course, you got all the sheathing and the, the actual valve and all that stuff.
As well as NASA Test Director Jeff Spalding.
I want to see the cameras.
GLS is pre-tensioning
what are we going
the
to see?
umbilicals at this very moment. You can see them as they run down the rocket. That's getting them ready to detach. At liftoff, those arms will swing away. We'll let go of the rocket in a clockwise direction. T-minus 8 minutes and counting. The GLS is performing up to 100 commands per second.
Woo!
Including configuring ground systems for power transfer to the rocket. GLS is turning on cameras, recording video inside and outside the crew module to collect data for engineers. Purging the aft skirt booster with high flow nitrogen. Clear out any hydrogen gas that may be there.
Yeah, the nitrogen inerts the oxygen. That way there's no boom if the hydrogen gets too high.
You can see the crew access arm is already retracted. When there is
no
crew during Artemis 2, it would happen at T-minus 6 minutes. But out of abundance of caution, they went ahead and retracted the arm well ahead of liftoff. Want to point your attention to the base of the mobile launcher. If something wasn't done to reduce the power from the pressure caused by the rocket's ignition and thunderous sound, it could damage the rocket. So the ignition overpressure and sound suppression system will flood the mobile launcher with water. You'll see that sequence start.
It's like a million gallons a minute or something like that.
Now coming up in less than 30 seconds, the ground launch sequencer will start bringing the high energy systems online, starting with core stage pressurization.
Come on, y'all. I don't care if you believe in science or not. You know this is fucking cool. But you better believe in science.
Firing room 1 is
belief.
Completely silent.
Science works. That's the point. Wow, I got really political there for a second, didn't I? I'm getting sleepy.
Tank is now pressurizing to flight levels. The replenish valve to the liquid hydrogen tank now closing.
Dude, that camera's toast.
The liquid oxygen tank will come a little later. Now we're arming the Orion ascent pyros and transfer to internal power.
Too bad it's not daytime, because it's going to be tough to see some of this stuff once it gets really high up.
The launch abort system, or LAS jettison motor, is now armed. On this flight, the abort motor is inactive because there is no crew on board. Up next is the flight termination system, or FTS, which gives the Space Force the ability to destruct the rocket if it goes in the wrong direction. Let's listen in for that.
I literally just leaned my ear to hear. I've got headphones on.
Go for FTS arm.
The flight termination system is now armed. Coming up at 4 minutes and 40 seconds,
the
a big
dance.
This is
has
where the
to go
RS-25
into everyone
engines
knowing their job and when to do
go
their
to high
job,
flow.
and
It's been a little
when
tricky
to
to dial
be
in.
quiet and let somebody else talk, and knowing the entire procedure backwards and forwards, inside and out.
LH2 high flow bleed check.
Just amazing, phenomenal.
Good word, we've passed that. The cryo team got the LH2 engine bleed pressure loop dialed in. They are now at the right temperature for launch. Countdown continues. T-minus 4 minutes, 15 seconds. Up next, GLS fires up the CAPUs. Those are high-speed turbines which provide pressure to hydraulic pumps that steer the RS-25s. Stands for Core Stage Auxiliary Power Unit Start.
GLS is go for core stage APU start.
That now leads to the thrust vector control test at T-minus 2 minutes and 30 seconds. That can proceed now, and we will see the engines gimbal at the bottom of the core stage.
Make sure they can actually swivel around. Oh, I got goosebumps everywhere.
At T-minus 3 minutes and 10 seconds, you will hear the go for purge sequence 4. That's a helium purge of the 4 core stage engines downstream of the propellant valve, getting the air and moisture out.
Just prevent misfires and cavitation.
And in just a few seconds, GLS will close the core stage LOX vent, liquid oxygen.
And to mix with the
The
fuel.
white vapor cloud causing the super cold gaseous oxygen condensing the water in the atmosphere will disappear. You see it coming out there now. And there it goes, it's closed. LOX vent closed, pressure rising in the core stage LOX tank to flight levels. Coming up in 15 seconds, look for that thrust vector control actuator test. Engines will gimbal.
That's so fucking cool.
Oh,
look at him go!
The 4 core stage RS-25 engines gimbaling around, testing the ability to steer the rocket into space.
That's so fucking cool.
They will operate at 109% performance. Each RS-25 throwing down 500,000 pounds of thrust. All 4, 2 million pounds. All together with the boosters,
42 million pounds of thrust.
Stage to internal power.
Now the upper stage has gone to internal power. So power is removed from the rocket's upper stage, the ICPS, and it's been switched to battery power. The same milestone is coming up for the core stage at T-minus 1 minute and 30 seconds.
GLS go for core stage to internal power.
Oh, there we
the
go.
rocket's core stage, which houses the 3 flight computers, is now on battery power. So there is no more hold time available because there's no more margin on the batteries. So if we have a hold, we'd have to recycle back to T-minus 10 minutes and recharge those batteries.
Those are very short batteries.
A note now, shortly after liftoff.
1 minute.
Shortly after liftoff, Mission Control Houston will take control of the rocket, and my colleague, Leah Cheshire, will take over commentary. T-minus 50 seconds and counting. Coming up at T-minus 33 seconds, the GLS will hand off control to the ALS. This is the autonomous launch sequencer. On board the rocket, it will take over command and control of the rocket. But the ALS will check, make sure there's no holds coming from the ground up until T-minus 2 seconds.
GLS is go for ALS.
And we are go for ALS. The Space Launch System is now counting down to liftoff.
What a milestone.
Of its maiden voyage to the moon. Launch team can no longer cycle the count.
1972 to now. 50 years.
Sound suppressor water now flowing under the ML. And here we go.
Oh, shit.
Hydrogen burn-off igniters.
Here we go.
7.
There goes that water.
5.
4.
Stage engine
3.
start.
2.
3.
1.
2, 1. Boosters in ignition.
Let's go!
And liftoff of Artemis 1.
Oh!
We rise together back to the moon and
oh,
beyond.
Shit! Look at the power.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters.
Fucking we have liftoff!
128 miles per hour.
Dude, my legs are goosebumpy. My arms are goosebumpy.
Carrying good control on the roll from teams in Mission Control Houston. All good calls. So
I'm shouting into my microphone. Sorry.
Flight of Artemis 1. First milestone will be for the vehicle to pass through max Q in about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket.
Wow. It's its own little star.
SLS now traveling 607 miles per hour.
Whew! Wait!
You're looking at 8.8 million pounds of maximum thrust. Quiet here in the loops in Mission Control.
Good Lord.
Throttling down ahead of passing through max Q.
Good Lord, look at that. The sound.
Now 1 minute, 21 seconds into the flight, traveling at 1,420 miles per hour.
Oh, shit!
The 4 core stage engines are back at maximum thrust.
Yeah.
The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and 11 seconds into the flight, so about 30 seconds from now. Again,
Keep the
quiet
camera
here
on
in
it.
Mission Control Houston as teams continue monitoring the flight of Artemis 1. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour.
Can you imagine being on that thing? The amount of G's.
Standing by for solid rocket booster jettison and shortly thereafter.
There we go! There we go!
Confirmation that the solid rocket boosters have separated.
Look at
Those
that!
177-foot boosters. Now the core stage continues to power the flight of Orion, all 4 RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange.
Wow.
2 minutes and 36 seconds into the flight. Hearing nominal calls here in Mission Control Houston. We've still got 4 good engines on the core stage. Next up, we'll be looking for the service module fairing to separate. This is 3 15 by 15 foot fairing panels, providing structural support, protecting the service module. Those will separate at about 3 minutes and 11 seconds into flight, and very shortly thereafter will be followed by the launch abort
that thing is
system
bouncing
separation.
around. Wow, that thing is bouncing around.
Just over 3 minutes into the flight of Artemis 1, now traveling over 4,060 miles per hour, 83 miles downrange. We just had confirmation that the service module fairing has separated. And that the launch abort system pyros have fired, separating those from Orion as well. For future crew members...
Uh-oh. You got cut off, lady. Leah, you got cut off.
We just heard the call for 3-engine press, meaning if SLS were to lose an engine at this point in the mission, we could still achieve a nominal mission. We would just have an extended main engine cutoff time. However, we still have 4 good engines, all at maximum thrust right now, powering the first flight of Artemis at 5,200 miles per hour, 148 miles downrange.
That's insane. In just a couple minutes, wow! What amount of power.
We're 4 minutes and 16 seconds into the flight of Artemis 1. So far, we've had a clean ascent. We saw those solid rocket boosters jettison about 2 minutes and 11 seconds after liftoff. Shortly after, we had the service module panels fairings separate, as well as the launch abort system. The launch abort system was inert for this flight, except to perform this separation. Those 4 core stage engines will continue to fire and power the flight of Artemis 1.
18 minutes, right?
Now traveling over 6,800 miles per hour, 229 miles downrange. Booster flight controller reports that the engines are looking good.
Wow.
Our core stage main engine cutoff time is about 8 minutes and 3 seconds. We are now 5 minutes and 11 seconds into the flight, 7,656 miles per hour. Again, 4 good core stage engines, those 4 RS-25 engines. The last time those core stage engines flew, they were taking space shuttles to orbit, and now with upgraded capabilities, they're launching the future of human spaceflight. 5 minutes, 42 seconds into the mission. We are now traveling 8,800 miles per hour, 345 miles downrange from the launch pad at Kennedy Space Center.
I was hoping there was going to be cameras on the front of the
core stage main engine cutoff at about 8 minutes and 3 seconds. And about 10 seconds later, we'll see core stage separation, at which point Orion and the interim cryogenic propulsion stage will be flying free. Now traveling over 10,000 miles per hour, 6 minutes and 15 seconds into the flight of Artemis 1, 427 miles downrange. Quiet here on the loops in Mission Control Houston. Teams continue to monitor this first flight.
6 minutes into a 26-day journey.
About a minute and a half now until that core stage main engine cutoff time. Our 4 core stage engines continue to fire maximum thrust.
Wow. I just,
Coming up on 7 minutes since
guys,
launch today, now traveling over 12,800 miles per hour, 563 miles downrange. Again, still quiet here in Mission Control Houston.
Wow.
As we prepare for main engine cutoff, the 4 RS-25 engines are beginning to throttle down.
There's
30 seconds now until core stage main engine cutoff. All 4 engines continue to throttle down. Now 7 minutes 45 seconds into the flight, traveling over 16,000 miles per hour.
So the circumference of the Earth is roughly
Continuing
about
to hear good calls
25,000
here in
miles.
Mission Control Houston.
So
we're standing by for core stage.
We're getting closer and closer to being able to go around the Earth an hour. Wow.
And we have confirmation of core stage main engine cutoff. Orion and it's now
We're
in
not quite
Earth's
on the
orbit.
equator though, so it'll actually be.
The flight dynamics officer reports that we have a nominal main engine cutoff. And we just heard the call for core stage separation. That means Orion and the interim cryogenic propulsion stage are now flying free from the core stage of the Space Launch System. The next milestone will be solar array deploy approximately 18 minutes after liftoff. But before Orion stretches its wings, let's check back in with our friends at Kennedy Space Center and hear all about what it was like to hear the rocket roar off the launch pad. Megan and Kayla, I've got to hear all about it.
Right? It had to be
well,
loud.
if you're just joining us, welcome to NASA's Kennedy Space Center, where we just watched Artemis 1 launch, our first step towards our next adventure into deep space. As Leah said, I'm NASA's Megan Cruz, and this is NASA astronaut Kayla Barron. And I'm kind of still giddy and speechless. I don't even know how to explain how I'm feeling right now.
I feel the same way. This is the first launch that I've been able to watch in person. And I've got to say, it was incredible. It took my breath away, and I was tearing up. Just what an amazing accomplishment for this team, this international team, people who have been dedicating their careers to getting this rocket off the ground and taking the first step to getting a crew on that vehicle back to the moon. It was just incredible.
Yeah, this is a moment I think that we're all going to remember where we were when we saw this sort of thing, you know what I mean? And it was great to see, again, when we entered into terminal count, everybody here just started cheering, coming out to get a really good view. And boy, I mean, it lit up the night sky, and it just shook everything around us. Did you feel that? Like in my bones, I felt that.
Oh yeah, the cool thing is just kind of the delay between what you see and what you hear, because of course the sound travels a little bit slower, and it was just amazing. The ground shook. We could hear the thrust pushing that rocket into space. 8.8 million pounds of thrust.
Yes.
It's incredible. It was amazing to see here live in person.
How does it compare? So this is your first launch on the ground. How does it compare to your launch when you're in the capsule soaring towards space?
I mean,
let's see.
Equally emotional, I think. We train for everything, and so when we're in that capsule waiting for launch, we're just running our procedures. You could almost, trick us and say that we were in the simulator and it wasn't real, but like in that moment of liftoff, when the thrust builds underneath you, like we saw it today, it's just hard not to be overwhelmed by the emotional experience, the excitement, the joy of that moment. It's incredible.
Yeah, I think we can't say it enough. This team really deserved this moment. They've been working so hard for this moment. When I heard that we got into terminal count, it was, I felt a sense of relief and excitement for them that I think everybody here did. We really wanted them to succeed. We really wanted to see the launch today. And wow, I will never forget this.
Me neither. It was an incredible experience to be here and see that happen.
Yeah. Was there anything that was particularly surprising to you? Again, this is your first launch. You know, what were you expecting?
Okay.
You know, I think we also had a nighttime launch for our launch. And so I think one thing you underestimate is how much it lights up the night sky.
Yeah.
Oh, yeah.
We were able
So
to
my
watch
Dodge
it
Journey
all the way through that
produces
trajectory. We were able to see the boosters separate
95,150
and everything.
foot-pounds
so it was
of
just an
thrust
incredible view.
at
It's
max
amazing how much
horsepower,
you
which
get
it
to
never
see of the
achieves
flight
because
path
it's a
when
piece of
at
crap.
night and sliding up the sky.
Yeah,
And
I
that
don't know if you
produced
noticed this, but we see the
8.8
moon
million.
here, and the trajectory of the rocket looked like it was flying towards me. You know what I mean? I was like, oh my God, that's so poetic. It's so beautiful. I'm so glad we launched today.
Yeah, my Dodge Journey didn't even do 1%.
It's incredible.
We're going to head over to
of
Daryl,
that.
who was at the launch team. Daryl, you got to count us down through that, through liftoff. I mean, how was that being in the launch control center with them?
Well, Megan, it was something else. I got to tell you, you're looking live inside the firing room where Charlie Blackwell Thompson is about to address her team after a whole lot of hard work and preparation to get to this moment.
Yeah.
Let's stand by and listen to her now.
I saw some stupid conspiracy theories online too.
Comm check. But you can't hear it in the room. Can you guys hear me? No.
We just launched a rocket, but we can't do comms inside a building.
The room can't. You can hear me? It's the guys.
Get a megaphone.
I don't know what he's telling me to do.
A fucking microphone doesn't work. We can launch a rocket to the moon, but we can't get a microphone to work. Damn IT. It's always IT. Get up there and sing, girls. It's karaoke. What a cool feat. You guys, wow. Absolutely phenomenal.
He's here.
Can you guys hear me? Oh, there we go. Is he ready for me? Well, for once, I might be speechless. So you guys know I have talked a lot about appreciating the moment that you're in. And we have worked hard as a team. You guys have worked hard as a team for this moment. This is your moment. It is not by chance that you are here today. So I want you to look around at this team and know that you have earned it. You have earned your place in the room. You have earned this moment. You have earned your place in history. You were part of a first. Doesn't come along very often. Once in a career, maybe. But we are all part of something incredibly special, the first launch of Artemis.
50 years. Back to the moon.
The first step in returning our country to the moon and on to Mars. What you have done today will inspire generations to come. So thank you. Thank you for your resilience. You know, I said at the pre-test briefing, the harder the climb, the better the view. We showed the Space Coast tonight. What a beautiful view it is. So congratulations. So we got a couple of traditions here in launch control. And the first one is when you're in the position for the first time, you get a tie cutting. And so I have my launch director scissors. And I'm going to get my tie cut by a couple of legends that are here. And then anyone who wants their tie cut will be making the rounds in the firing room. You got your console chiefs, if they want to do it, that's fine. If you want me to do it, you might have to wait a little while, but I'll stay all night if I have to. It'll be my pleasure to cut ties. So I'm going to take care of mine, and then I have one other presentation that I want to make this evening.
I don't know anything about this tradition. I wonder what this symbolizes. Your scissors need to be sharpened. Don't stab him.
This is Charlie Blackwell Thompson, Artemis 1 launch director. She just got her tie cut. That is a tradition here at NASA. We just got to hear her talk to the team, and one thing that really stuck out to me that she said is that they've really earned their place in history. We're coming up on solar array deploy. Let's go on to Leah.
Thanks, Megan. And yes, we're here in Mission Control Houston, still monitoring the Artemis 1 mission and the first flight of Orion atop the Space Launch System. So far, we saw successful liftoff at 1:47 a.m. Eastern Time, all the way through separation from the core stage. We now have Orion and the interim cryogenic propulsion stage flying free. And we've just heard that we have initiated solar array deploy. So we are turning our focus to that. The spacecraft was running on battery power, but stretching these wings will allow it to stop relying on those batteries and significantly extend the time it can stay in space. So solar array deploy takes about 12 minutes. We have 4 solar arrays that we need to deploy and latch. These will provide power to the spacecraft on its journey to distant retrograde orbit and all the way back to Earth. Once these are properly configured, again, Orion will no longer need to rely solely on battery power. And we expect this to be done about 30 minutes after liftoff. Right now, we're 19 minutes since liftoff today. Orion is now traveling 17,175 miles per hour.
Woo.
We're continuing to hear good calls here in Mission Control Houston from the flight controllers monitoring the mission. A little bit about these solar arrays as we wait. Again, we heard the call that the deploy has been initiated. We'll hear a little bit more about that once they start to unfold. These 4 solar arrays generate 11 kilowatts of power, which is enough electricity to power 2 3-bedroom houses, and they have a wingspan of 63 feet. Just one of these 6.5 by 6.5 foot panels has 1,250 solar cells. So you're looking at a total of 15,000 solar cells. Now, we just heard the call that all 4 solar arrays have been released. So we initially heard the initiation call. That command had been sent. Now those 4 solar arrays are released. Again, this is about a 12-minute process.
Ooh, ooh. Ooh.
These solar arrays will deploy straight, and you're getting a live view right now. This is really exciting. They'll eventually be swept back against the vehicle prior to translunar injection burn to prevent any loads from breaking or damaging the arrays. And on the end of each solar array is a camera that will capture imagery for us throughout the mission, along with a few other cameras placed outside and inside the spacecraft to help us monitor and perform various other inspections.
How cool.
Of course, if you recall the Apollo capsule design, there were no solar arrays. We had fuel cells instead. So this design with arrays gives us the opportunity to stay in orbit longer, since we practically have no limit to the energy available for use from the sun. Coming up on 21 minutes since liftoff. Orion is attached to the interim cryogenic propulsion stage. You can see those 4 solar arrays unfolding now. And again, Artemis 1 is a flight test. It's paving the way for a sustainable presence at the moon. Looking forward to the future, Gateway will be our space station in lunar orbit. And we have some similarities and differences in the solar arrays unfolding right now on Orion and those that'll be on Gateway. So like we're seeing now, these are deploying autonomously. The Gateway solar arrays will as well. And while these generate those 11 kilowatts of power, the 2 rollout solar arrays, or ROSAs, on Gateway will generate 60 kilowatts of power. That ROSA design is currently being tested aboard the space station. We have 2 new ones installed and a spacewalk conducted earlier today, preparing for another set.
Yeah, I did watch that earlier on the ISS. I was watching a live feed on TikTok, of all things,
Coming
of
up
the
on
spacewalk.
22 minutes since liftoff today, Orion and the interim cryogenic propulsion stage traveling over 16,800 miles per hour. The solar arrays deploying now are part of the European Service Module. It's comprised of 20,000 parts and components. The service module was developed as part of an agreement between NASA and the European Space Agency, or ESA. This is the first time NASA is using a European-built system as a critical element to power an American spacecraft.
What a lot of data going on there. Good Lord. That's the kind of charts I like to see, not stockbrokers. Capcom, FAO, MAO. I used to know what all those stood for. Capcom and FAO, MPO. I used to know what all those acronyms were. I think Capcom's a capsule communication, right? What are those? Internet to the rescue. Mechanical and Power Officer is MPO. FAO is the flight well, it says Flight Auxiliary Officer, maybe. Let's see.
Coming up now, and 24 minutes into the flight of Artemis 1, spacecraft now traveling at 16,500 miles per hour around the Earth. We are in solar array deploy, and we have confirmation all 4 arrays are deployed.
Oh, here we go. FOD is Flight Operations Directorate. Capcom is the Spacecraft Communications, which we kind of knew that one.
Coming up in a little less than 30
PAO
minutes is the perigee raise
Affairs.
maneuver.
Oh, is that PAO for Public Affairs? Oh, Flight Activities Officer, that's FAO. A whole lot of positions. Flight Dynamics. And we've got civilian stuff now, too, with SpaceX. They've got different positions. I want to zoom in and look at all their little pieces of data. See what exactly they're looking at. It's a lot of information. Hey, don't get off your desk. You got work to do. Get off your laptop. It's not time to watch TikTok. Get back to your desk. That's right. You better sit down and do your job. Oh, look at that. How cool. Come on, go back to that. That was a cool image.
With our launch at 1:41 Eastern Time this morning, we are looking for a perigee raise maneuver about 53 minutes into today's flight. Again, we are now 25 minutes and 47 seconds into the flight, and we have a complete deployment of all 4 solar arrays. Orion's journey to the moon continues as planned. Again, looking forward to that perigee raise maneuver. That'll be coming up again at about 53 minutes into the mission, so about 27 minutes from now. During the perigee raise maneuver, the interim cryogenic propulsion stage will use its RL-10 engine to lift the lowest point of Orion in Earth's orbit. The current orbit is more of an oval shape than a perfect circle, and this burn will raise that point closest to Earth
Perfect
and
circle?
make
I
the
love that
orbit
band.
more circular. This will also include a checkout of Orion's systems and any adjustments to the solar arrays. It'll be a short burn, less than 30 seconds long, but critical to keep us on track, and it also prepares us for the next engine burn to send Orion to the moon. That's the translunar injection burn. That'll come up a little later, which is a longer burn, another firing.
All right, guys, I think we're going to go ahead and call it from there. We got to see the launch. That was the main part. Now we've got 26 days of it traveling and traversing from Earth all the way to the moon and back again. We may have some updates here and there. Like I said, I want to update on the JWST, the new OSHA, NOAA satellite that's up. Got to do this as well. We got a lot of stuff we need to update. I'd like to learn more about the Chinese space station that just got completed this week. So we might have a video. I need to make more of these videos talking about my passion and love of space and everything like that, instead of just these quick reacts, which 2 hours. It's not really a quick react, but I was super excited. Now I get to stay up even later to edit this and then post it out for you guys. But thanks very much for coming along on this journey to watch this. It has been a long time coming, many years of research and development, building, and then 8 or 9 delays now due to weather and hydrogen leaks and the Queen's funeral. But we got it. It's launched. It's up in the air. We know that it works. 26 days from now-ish. The re-entry, that's the big thing. We want to make sure that that heat shield is going to protect the astronauts on re-entry. 20,000 miles an hour. Woo-wee! So we'll be looking out for that. Probably here. Hopefully I'll be off of work and I'll be able to react to the re-entry because I'm sure they're going to cover that as well. And we also have some SpaceX stuff that we need to cover as well. So thanks very much for watching, guys. I'm going to put some links down below to like the hydrogen valve videos and whatnot because it's really interesting. It's just super nerdy, geeky engineering stuff that kind of helps you to understand the hydrogen leaks they were having and the concerns, as well as... yeah, my mind is blank. It's really, really late at night, and I've been up for almost 24 hours now. So with that, don't forget to hit like, subscribe, comment, share with the universe. ZomBo Skater saying goodbye. See you later.